In this movie, I'd like to talk about proportional scaling. So, all of the families that we've worked on so far throughout the course have had flexibility in at least two directions, the x and the y, and in some cases, we've added other parameters as well. But in almost all cases, if we flex the x or the y, it has no impact on the other. In other words, we're able to stretch our families in any way that we want. We have complete freedom in both directions. Well, there may be times when you want to actually set up certain fixed proportions. So you always want the height to be twice the width or something along those lines. You could do that very easily by just setting up formulas in the family. And if you did the trigonometry formulas that we did in the previous chapter, then these are pretty simple by comparison. But in this movie, I'd like to go through some examples of building the proportion, sort of a fixed proportion, directly into the profile families that we're going to use. So I'm in a file here called Profile Flex, and it's just using a square profile right now. So if I select this sweep on screen here and scroll down, you'll see that I've got a profile called Rectangle Profile, and then it's got a type called 8x6. So you can see that down here on the Properties palette as well. Here's the Rectangle Profile family. Here's the 8x6 type. And if I right-click and edit its type properties, there's the 8 and there's the 6. Now, there currently is no limitation. So if I decided to change x to 1.2 and click OK, it will happily stretch the x direction without any impact on the y. So what I want to do is set up a relationship where if I change one, it actually modifies both of them. So let me reset that back to 0.6 and click OK. I'm only doing 0.6 just so it matches the name. And then let's right-click Rectangle Profile, and I'm going to choose Edit. Now that'll open that family. And of course, you can see that there's a y direction and an x direction, and we just have a really simple rectangular shape here. To do this, all you need to do is go to Family Types and put formulas in right over here. And we've seen some examples similar to this before, so this is not a terribly new concept here. But let's go ahead and put in a formula. So if I wanted to maintain this proportion that you see on screen here, I could say that it's y times 0.75. And you'll notice that nothing changes on either side because I've done the calculation to maintain that proportion. But now if I click in either field and I put in a new value, it will also change the other one. Now, it goes both ways when you do these simple arithmetic formulas. So if you come in here and you put in 0.5, that will force the y to change as well. So by putting in a single formula, you're actually tying both values together and it works in both directions. That's not true of every formula you create, but it is true of any arithmetic formulas. They always work bidirectionally. So if I apply that, very simple. Now, if I were to load this back into the project, it would be maintaining that proportion. So now 8x6 doesn't really mean a size per se. It's more of the relationship. So perhaps I want to rename that. And instead of 8 times 6, which kind of implies that those are fixed numbers, I'll put in 8x6, which maybe implies that that's more of a proportion. Okay, and I'll click OK, and I'll load this back into my project, overwrite the existing. And when I do, nothing really changes too much on screen here. And an interesting thing happened down here on the project browser. Now, this is something you may be familiar with if you've worked in the family editor before. The 8x6 type that was already here, we renamed it in the family editor, but it's still here. So Revit won't delete a type that you already have. And it certainly wouldn't delete it because if you look at this sweep, you can see that it's actually still using that type. So if Revit deleted that type on us, it would actually delete our form. So they won't go ahead and delete that type, but now I could switch to this one. And when I apply, you can see that the shape just adjusted a little bit because it's now using the new proportional one. So then this one is no longer necessary. I can simply delete it. But it's kind of important to understand that if you create a new type in the family editor that's different from the type you created in the project, you might end up with some of these leftover types hanging behind. So it is a good idea to clean that up. But anyway, if I right-click here and go to Type Properties now, even though I'm no longer in that family editor, if I change the values here, the formula still applies. So I can't make these go out of sync. No matter what number I put here, it's always going to maintain an 8x6 relationship. And so that's a really easy way to build in proportional scaling directly in the family. Now, you can do that with any of these profile families. So I provided a few others for you to experiment with if you'd like the Ovolo profile and the Kyma profile in the exercise files. It works exactly the same way. If you wanted to, you can come in here and put in the same relationship, y times 0.75. It's not going to change any of these formulas, but that just adds one more constraint, if you will, on the entire family. So now, regardless of what I edit either of these values to, it stays in this 8:6 proportion. And that's the only real change we've made. Meanwhile, depth is still unaffected. So notice here that the depth can still be anything that we want it to be. So if you also wanted depth to flex proportionally, you'd have to give it a formula as well. And it could also be something like, 0.5 plus y times 0.75 or whatever relationship you're trying to achieve. But it's as simple as that. If you want to get proportional scaling, you just have to take each of the parameters that want to be related to one another and make sure that they have that proportion built into them by just putting in a formula. It can be division or multiplication. They both work the same way, but it's going to be a bidirectional relationship.